Hi everyone. So the goal of this video is to go over some of the questions that might need some explanation on your midterm review. So I'm going to go over just a few of the questions. There are some that you'll see on the answer key that I'm not going to explain. Some are kind of self-explanatory once you see the correct answer. But I will go over a few of them. So number 4 is the first one that I'll go over. So you guys can read the problem for yourselves. I'll just quickly show you how to solve this one. So the key idea here was we were trying to find velocity. That's what we're trying to find. We know displacement and we know time. Now, if you were resourceful, you might have gone to the very end of the review and you would have found some useful equations right there. Velocity is displacement divided by time. So that's the equation that we're going to use for this problem. So quickly back to our problem here. We just do velocity. Or really, I could even keep it short, just go with V. V equals displacement. Sometimes we wrote that as delta x divided by t. All right, so for my first athlete, Thomas, he runs a 55-meter dash. 55 meters is about 60 yards. Pretty common for baseball players to run a 60-yard dash and to see how fast they are. 6.7 seconds. Do that in your handy-dandy calculator. 55 divided by 6.7. So we have 8.2. Remember, your units for that are meters per second. Meters per second. Okay. You could do the same strategy for Amir. He's a football player. He runs 36 meters. That's about 40 yards. Very common running time or running displacement for a football player. And then their time in seconds. Divide this by this to get their velocity. And then you can figure out who's fastest. Whoever has the higher velocity is the fastest runner. All right. Number 5, we have a soccer player that runs from midfield to the goal box. They move from a position of 50 meters to a position of 82 meters in 4.5 seconds. What is the player's velocity? So again, we're trying to find velocity. You can imagine a soccer field. We have this player is going from midfield to the goal box. So to this point right here. Okay, so this is how far they went. We know their starting position was 50. We know their finishing position is 82. All right. And they did that in 4.5 seconds. So if we're going to write down what we know here, we know that their initial position was 50, their final position was 82, and their change in time, how much time passed by, was 4.5 seconds. Velocity is your change in displacement. That would be your final position minus your initial position divided by the change in time. All right, so that would be 82 minus 50 divided by 4.5. All right, 32 divided by 4.5, and then you guys can maybe do the calculation. Maybe I'll just do it really quickly. So 32 divided by 4.5. She got 7.1. 7.1 meters per second. Make sure you give me your units. Give me your units for every time I give you a question. All right, number 6, position time graph. I think a lot of people did really well when I was going over the review for some of the classes that I went over this with. Let's just quickly go over it. So we're talking about from here of time equals 6 to time equals 14. So that's where we started and where we ended. You want to describe the motion and then find the displacement. Well, I would say that this person was staying still. They're staying still, and then they moved in the negative direction here, and then they stayed still. All right, so there was no movement. They're moving in the negative direction here, and then they were staying still. So that's what I would say in my description. And then if I was trying to find their displacement, well, it looks like they started at 10 and they ended at 6. So their initial position was 10. Their final position was 6. And so their displacement is final minus initial. Final minus initial. And that would be 6 minus 10, which is -4. -4 meters. Okay. Next question, acceleration. So we want to find the acceleration. So that's what we don't know. What do we know? Well, we know its initial velocity because it goes from 3 meters per second to a final velocity of 20 meters per second. And it does that in 4 seconds. So we have our initial velocity is 3, our final velocity is 20, and our time is 4. So the equation for this, it's very similar to displacement. We want to do final minus initial. So final velocity minus initial velocity divided by the change in time. Acceleration is equal to 20 minus 3 divided by 4. That's going to be equal to 17 divided by 4. Off the top of my head, what is that, 4.25? 17 divided by 4. Yes, 4.25. All right, and that's a change in velocity, right? We're trying to find an acceleration. Our units should be meters per second squared. Okay, I might have one more to do in this video, and then I might have to make a second video. Let's see how quickly I can do these ones. Well, these are both about, well, the next three are all about force. Actually, let's just stop here and we'll have a separate video for force.